Hi, welcome back to SQL Database Administration Hub. Today, we're troubleshooting memory and CPU problems in SQL Server.
These are two of the most common performance complaints DBAs deal with, and knowing how to diagnose them quickly is an essential skill.
Let's get into it.
Memory and CPU are the two most fundamental resources SQL Server relies on.
When either one is under pressure, everything suffers. Queries slow down, response times spike, and users start complaining.
The challenge is that memory pressure and CPU pressure have different symptoms and different root causes, and they need different solutions.
In this video, we'll cover how to diagnose and resolve memory pressure, how to diagnose and resolve CPU pressure, and the most common configuration mistakes that make both problems worse.
The SQL Server manages its own memory aggressively. It grows the buffer pool up to the max server memory limit
and holds on to that memory. It doesn't release it back to the OS unless another process needs it. This is by design and is normal behavior.
Memory pressure occurs when SQL Server doesn't have enough memory to keep frequently accessed data pages in the buffer pool, forcing it to constantly read from disk. Signs of memory pressure include high PAGEIOLATCH wait times, frequent page life expectancy drops,
and high physical I/O on your storage.
Page life expectancy, PLE, is the most important memory health metric. It measures how long, in seconds, a data page stays in the buffer pool before being evicted.
The traditional guideline is that PLE should be above 300 seconds. For servers with large amounts of RAM, the threshold scales.
The common formula is 300 seconds per 4 GB of buffer pool. You can monitor PLE with this query.
Select object name counter name stir value from system of performance counters where counter name page life expectancy.
If PLE is consistently low and dropping, investigate with SysDM OS memory clerks to find which components are consuming the most memory.
Often a runaway query with an excessive memory grant, an overgrown plan cache, or a third-party process consuming RAM outside SQL Server's control is the culprit.
CPU pressure manifests as high SOS scheduler yield waits. Queries taking longer than usual?
Windows Task Manager or Resource Monitor showing SQL Server consuming near 100% CPU.
The first step is identifying which queries are consuming the most CPU. Use sysdm exec query stats.
Select top 20, total worker time, execution count as average CPU time. Total worker time, execution count.
Scrimp ttext 1300 as query text from sysdm exec query stats s. Cross-apply sysdm exec seal text, order by total worker time DSC.
Once you identify the top CPU consumers, investigate their execution plans. High CPU is almost always caused by one of three things: missing indexes forcing large scans, excessive recompilations causing SQL Server to rebuild execution plans repeatedly, or inefficient query logic like cursors or scalar functions that execute row by row.
For recompilation issues, check sysdm exec query stats for queries with high execution counts but a plan generation num greater than 1.
Indicating the plan has been regenerated multiple times. Parallelism can both help and hurt CPU usage. Parallel queries can complete faster but consume multiple CPU cores simultaneously.
If many parallel queries run concurrently, CPU saturation can occur. Tuning your max stop and cost threshold for parallelism settings, which we covered in the configuration video, is often the right solution.
Both memory and CPU problems are frequently made worse by configuration mistakes that are easy to fix once you know about them.
For memory, the most common mistakes are not setting max server memory at all, letting SQL Server consume everything and starve the OS,
And setting it too low, leaving SQL Server memory starved even when the server has plenty of RAM available.
Review your max server memory setting and make sure it follows the guideline of leaving at least 4 GB or 10% of total RAM for the OS.
Another memory mistake is having too small a tempDB. When tempDB runs out of space, operations that rely on it spill to disk.
causing performance spikes that look like memory problems but are actually tempDB configuration problems.
For CPU, common mistakes include leaving maxstop at 0, allowing single queries to consume all CPU cores, and having the cost threshold for parallelism set too low, causing SQL Server to parallelize even simple queries that don't benefit from it.
The cost threshold default of 5 is almost universally considered too low. Most DBAs raise it to 25 or 50 as a starting point.
Another CPU mistake is missing indexes on frequently queried large tables. Table scans are dramatically more CPU-intensive than index seeks.
And a single well-placed index can drop a query's CPU consumption by orders of magnitude.
And that's memory and CPU troubleshooting covered. To recap, memory pressure shows up as low page life expectancy and high PAGEIOLATCH weights.
And you diagnose it with sysdm-os memory clerks to find the components consuming the most RAM.
CPU pressure shows up as high SOS scheduler yield weights and near 100% CPU usage, and you diagnose it with sysdm-exec query stats to find the queries consuming the most worker time.
And the most common configuration mistakes: unconfigured max server memory, max DOP at 0, and low cost threshold for parallelism
are quick wins that can dramatically improve resource utilization with minimal effort. Memory and CPU problems are everyday DBA work. The faster you can pinpoint the root cause, the faster you can restore normal performance and keep users happy. Subscribe so you don't miss the next video, and I'll see you there.